Hello everyone, welcome to the video lecture series of Internet of Things. In today's lecture, we are going to discuss topic RFID principle and components. I am Professor Swati Suresh Pawar. Before starting with today's lecture content, let us revise the contents of the previous lecture. In previous lecture, we have studied definition of sensor, types of sensor, types of actuators, example and working of sensors and actuators with few examples. Now let us discuss RFID principle and components. Introduction first. One of the internal aspects of the IoT is the identity. The recognition of true identity of device, user, services, etc. makes the IoT system successful. There are many ways available to collect the identity of the assets, devices and users. For example, MICR, that is machine reachable character, smart code, smart cards, barcode, magnetic strips, retina scan, fingerprint scanner, etc. These technologies of identity recognition are mostly of two types. They recognize the objects when it physically contacts the object, that is contact type recognition, or when they came close enough to object to detect the presence of line of single path, that is proximity based techniques. The most popular identification mechanism in IoT today is RFID, that is radio frequency identification. It overcomes most of the bottlenecks of traditional IoT systems. RFID system consists of the RFID tag, which is also called the transponder. The transponder remains attached to the object which has to be identified. The tags normally have a tiny antenna and an integrated circuit. The reader tries to query the tag on radio frequency. Radio frequency waves are used to get the identity of the tag. Many ranges of radio frequency bands are used in RFID systems. Mostly they are used in the following bands. Low frequency, which is from 125 kHz to 134.2 kHz. High frequency, which is 13.56 MHz. Ultra high frequency is from 860 to 915 MHz. Microwave frequency, which is from 2.45 GHz to 5.8 GHz. Now the RFID basics. Radio frequency identification is the wireless identification service which is used to bind the device or things with unique serial number encoded within a tag. RFID tags can be recognized using RFID reader even without direct line of sight or direct contact. The communication between special tag and the reader happens via radio frequency. RFIDs are attached physically to the device which needs identification. Some additional data can also be stored on the device along with the serial number according to the size limitations. RFIDs can work on read-only, read-write, read-write, rewrite as per the need and encoding. RFIDs are frequently used for products where direct line of sight identification like barcodes cannot be used. Figure shows the RFID tags and communication. Where the computer is the end node device, there is a RFID reader and there are RFID tags. Principle of RFID. RFID uses radio frequency to communicate between the tag attached on a device and RFID reader that identifies the unique RFID tag which can be used for identifying, tracking the implemented object. Let's see in detail how RFID works internally and what the application of it are. RFIDs are attached physically to the device which needs unique identification. RFID tags store a serial number that identifies the object and some additional data can also be stored on the device along with the serial number according to the size limitations. RF signals are used by the tag to convey the message to the readers. The logical load represents state 1 and 0, that is switching on and off, are used for the purpose. With the help of this load modulation, the communication takes place between the tag and the reader. In fact, without any transmitter, Identity of the tag is transferred using this communication. The microchip located at the tag is responsible for storing the identity of the chip. The state machine or the processor is responsible for reading the load modulation and operating the switch. The clock signal is generated by oscillator which back up the battery. Some more sophisticated can operate without battery and power is supplied by reader itself. A diode in the tag is used to rectify the RF energy into electric signal. RFID provides low-cost contactless identification of devices. When the device comes in range of the RFID reader equipment, readers read this data on the tag using the radio frequency even without the actual contact. As shown in the figure, next RFID system contains a device implemented with RFID tag, a RFID reader, a middleware which can be used to specify business logic, if any, to process the data. For example, payment of vehicle on toll plaza. And the device that displays the processed RFID information, which can be desktop, laptops, or an individual systems. RFID tags are of three types, which are active, passive, and semi-passive. They are categorized on the basis of battery support. Figure shows the RFID tag communication. It consists of RFID tag device, then RFID reader, then the middleware, an application that displays the processed data. An active RFID tag has an onboard battery installed which broadcasts the signal all the time, while passive RFID tag doesn't have a battery support. Semi-passive RFID has a small battery installed which is active only when the tag is in the presence of an RFID reader. Principle of RFID. RFID is different from other three pillars of IoT in the sense that RFID is generally used with unintelligent object while M2M, WSN and SCADA are used for communication between intelligent objects. RFID technology is frequently used with RFID implants on animals, clothes, cards and books, etc. Before RFID barcodes and plain text were used for object and article identification, Universal Product Code, that is UPC, was used in USA and Canada for object identification and the tracking. European Article Number, that is EAN, which was developed after the UPC, was used in Europe, and Ubiquitous ID, that is UID, was used in the Japan for the same. RFID concept is also used to develop new technologies like Auto ID is an mechanism that uses the identification technology like RFID and manages automatic data capturing and storage of this information over the internet. Electronic Product Code, that is EPC, is designed to be stored on RFID tag to provide unique identification for a product. Example of RFID application with the standardization. A low frequency passive RFID is used for animal identification and tracking. Working frequency of it is 25 kHz. Standardization ISO 18000-2. A high frequency passive RFID is used for identification of books in a library, clothes at shopping malls and other objectives. Working frequency is about 13.56 MHz and standardization is ISO 14443. Remote control vehicle lock management system uses 400 MHz working frequency and standardization is ISO 18000-7. Vehicle identification and toll collection system uses long-range passive and active RFID reading with working frequency of 5.8 GHz and standardization of ISO 18000-5. Operating frequency band for RFID. Low frequency is from 125 kHz to 134.2 kHz. High frequency is from 13.56 MHz. Ultra high frequency is about 860 to 915 MHz. and microwave frequency is from about 2.45 gigahertz to 5.8 gigahertz. RFID components. Two most important components of the RFID are reader and the tag. The tag stores the identity and have the signal generation mechanism. Reader has the ability of reading identity of multiple tags. Identity read by the reader cannot be used for the actual purpose unless the reader is connected to network and information is gathered at the server. So the middleware plays an important role in RFID communication. The three important components are RFID reader, then RFID tag and RFID middleware. RFID reader. RF reader modulates the RF carrier as per the information to be transferred to the tag. Antenna is used to amplify and modulate the carrier. Reader also has the task of receiving the electromagnetic waves. These waves are backscattered by the RFID tag. The internal diagram and working of RFID reader is shown in the figure next. The antenna is the externally visible part of the RFID reader system. According to the order of wavelength, the antenna is designed in its size. For the purpose of proper isolation, the two antennas are kept apart from the transmitter and the receiver. There are some readers with a single antenna called the monostatic system RFID. Figure shows the functional block diagram of the RFID reader. RFID tag. The most elementary and basic RFID is made up of capacitor and a parallel inductor. These simple RFIDs can design to operate on HF band. In such system, resonance of around 13.56 MHz can be achieved with resonant circuitry made up of inductance and capacitance. In its basic working, whenever the tag is placed close to the reader antenna, it induces the back electromagnetic frequency. This is sensed by the reader's antenna. At many occasions, diodes in the tags are used to reduce the false alarm rate. Harmonic frequencies can be generated by the nonlinear elements such as diode. Tag can contain integrated circuit. Circuit make the bit smarter by storing some more information. IC can be attached to tag's antenna. IC also contributes at detector stage, which rectifies the RF coming from the reader. Capacitor contributes in removing the ripple from the signal. RFID middleware. RFID middleware consists of a software subsystem that separates the top level application and the RFID hardware. In a typical IoT application system, there may be several RFID tags and many readers, each contributing in the success of entire IoT application system. Such system needs some middle level software for intermediate processing of data received from RFID readers. The middleware can have business rule to filter the relevant data to send to label decision making system. Many types of pre-processing of data can also be applied at the middleware level. The middleware consists mainly of three things: the device interface, core processor, and the application interface. Device interface consists of drivers and device-specific software. It provides the data to processing unit for pre-processing. Core processor applies the filtering and pre-processing rule. It sends the data to high-level application via application interface. The application interface acts as a channel between the middleware and enterprise application. Summary of today's lecture. In today's lecture, we discussed the RFID basics, RFID principle, RFID components. Thank you.